Hello everyone. Today we'll see a very famous example called worker job assignment problem using YALMIP. This is a very classic problem for linear programming problem types where worker has to assign a certain job such that the total wages are minimized. So let us start the MATLAB with here the question is written uh, in words. So there is a matrix W whose I, comma jth value tells us the ith worker has got the jth job. Okay. So here the first worker takes 3 units of wage for first job, 3 units for the second job, and 5 units for the third job. Similarly, second worker takes 1 unit for first job, 2 units for second job, and so on. Okay. So this is the worker wage cost matrix. This would obviously be uh, a square matrix. Otherwise, the assignment will be asymmetric. Okay. So the constraint here is every worker should be assigned only one job, and each job should be assigned to only one worker. Okay. Do you understand that point? So in suppose our solution look like this. I'm just writing this format of a solution. So let's say our solution is looking like this. Okay. So what does this mean? That first worker is doing first job. Okay. So X is our solution. So first worker is doing first job. Second worker is doing second job. Third worker is doing third job. So you can see first job has been assigned only to the first worker. So all except the first, all should be zero. Similarly, in the case of second job, this should be uh, other than this one, all should be zero. And similarly for the third case. So we got a constraint that sum of elements of rows. So the constraint here will be row sum should be equal to 1. Okay. And also column sum should also be equal to 1. Okay. So this is our constraint. I'm just commenting it out because we will find the solution afterwards. Okay. Okay. So I should delete it. So we understood our constraint. So now we'll start with creating the variable in YALMIP. So I'm creating a binary variable. It is similar to STP where, but it as our answer is in binary, so we'll create a binary variable. So it is the n cross n binary variable. Okay. Now our objective function. So what should be our objective function should look like? Suppose this binary variable has n cross n elements. Here n is 3. I forgot to mention it. Right? So here it has 9 elements. There will be 9 variables. So if I have to find values of all the 9 variables, it should be either 0 or either 1. Okay. So should be 3 times x1, 3 times x2, 5 times x3 plus 1 times x4, 2 times x5, and all this should be added. So it should be something like this: 3x1 plus 3, 2 plus 5 x3, and so on. So I have a better way of writing this. We can write it like this: sum of w element-wise multiplication with x. Okay, so this will uh, give me the uh, row sum, and this will give me the column sum for all the row sum. Okay, so our objective function is defined. Now we'll define the constraint. So let us make a variable constraint. So now we have to do for all the n rows, row sum as 1. Okay, so I will run a loop for I is equals to 1 to n constraint is equals to constraint. I'm just stacking up the constraints. Okay, this it's nothing, just stacking up the constraint. So I had to take x sum of x of ith row in all the columns. So it will, for the ith row, it will add all the columns. Okay, so this should be equal to 1. Okay, so this basically is constraint for this basically is constraint for each worker gets exactly one job. Okay, this is for that. So we have to write another loop also. Let's say j from I to n. So now this is for each job has been assigned to exactly one worker. Okay, so constraint will be same in same manner. It will be piled up constraint. So now we'll write sum of all the rows of a particular column. So all the rows of particular column, particular jth column. Okay? So this should be equal to 1. Okay. So we have now formulated the constraints. Now we should give the options for the STP variable, STP setting. So I'm giving the STP setting. Solver is int lin program. I should keep the verbose 0 because I do not want to see the other data which will be printed. Optimize constraint objective and then options. So this will be in our solution. Sorry. Okay, we can check if this solution is perfectly solved or is there any some error. So we'll use our YALMIP error. Okay, now you can get the results. So x val will be value of x. So in x we'll get the solution. We can also get the minimum ways. The total ways is equals to value of objective function. So objective function value will give me the total minimum wage. So we can now run it. Okay, let us first clear the window. We'll now see here. Okay, it's successfully solved, and the optimal assignment is this. Okay, you can see the first job has been assigned. First worker has been assigned the job this of third job. Second worker has been assigned the second job, and third worker has been assigned fourth. You can play around with these variables. Suppose I give here change some values. Let's say oh, sorry, I can directly run it. Okay. So now you can see the assignment has been changed. Total waste has also been increased. It is obvious. Okay. So in this way, this problem can be solved. Thank you.